Okay, so let me give you a quick whistle-stop tour of radians, because I think they're important. So, what unit do you use to measure angles at the moment? Degrees, yeah. Now, what do you know about degrees? How many degrees are there in a full turn?
10.
In a full turn, sorry.
360.
360 degrees, okay? So at the moment you use degrees, and you basically say, okay, if I complete one full turn, one full revolution, that should be equal to 360 degrees. So what that basically means is that if you look at a circle, because I guess it is a circle, full turn, right? It basically means it's made up of 360 individual turns, okay? And each of those turns is worth 1 degree. But my question is, why? Why are there 360 of these little sort of turns in a full turn, in a full circle? Why?
Because there's 90, 90, 90.
Good, so 90, 90, 90, 90. Why else? But why does that mean that it's got to be 360? Why can't it be like 100 degrees in a full turn? Or 50 degrees in a full turn? Or 1,000 degrees in a full turn? Why has it got to be 360?
Because if we divide it for 4,
Yeah?
it will be like 90, 90, 90.
Okay, that's wrong, really good reason actually. So the reason is because 360, when you divide it by lots of numbers, so 4 or 5 or 8 or 9, they all come out as nice numbers, okay? So the first reason why we say that 360 degrees means a full turn, the first reason, is because it has loads of factors. And the reason why we're interested in it having loads of factors is because because we never really look at a full turn all the time. Sometimes we'll look at like a quarter of a turn, or a third of a turn, or an eighth of a turn. Like we'll look at fractions of a full turn. It means that each of those fractions will result in a nice number, okay? So it means that we'll get nice numbers for like half a turn, or a third of a turn, or an eighth of a turn, or things like that, okay? So it means that we'll get nice numbers that way. So that's one reason why we use 360, is factors. And actually, if I look at factors, well, 1 is obviously a factor of 360, 2 is, 3 is, 4 is, 5 is, 6 is, 7 isn't, but 8 is, 9 is, and 10 is. So look at that. The first 10 numbers, okay, every single number is a factor apart from 7. I think that's pretty good going. That's a really good feature. So it means that if we look at a fifth of a turn, that's going to be a really nice number, okay? Or a nice number, it's not going to be an integer. An eighth of a turn is going to be a nice number. Ninth of a turn, again, nice number. So that's the first reason, so really well done. There is actually another reason. Can you think of anything in nature that completes a full revolution in about 360?
Ball.
Sorry?
Ball.
A ball, okay. Something which is a little bit bigger than a ball but looks like a ball.
Earth.
The Earth, yeah? So the Earth completes a full revolution of a sun, so you do a full turn of the sun, in about 360 days. So 360 days to complete a full turn of the sun, or a full revolution of the sun. Okay, so that's another reason. So, I mean, I guess if you look at the philosophy of mathematics and where things come from, particularly in ancient Greek times, a lot of mathematics has its basis in natural phenomenon. Okay, so they really liked this. They liked the fact, first of all, it had loads of factors, but there's loads of other numbers that also have loads of factors as well. So the reason why they chose 360 is because they realised it took about 360 days for the Earth to complete a full revolution. That kind of felt right. The fact that 360 in revolutions was based in nature, that kind of felt nice. It felt like a nice mathematical thing. But are you happy? So these are the two reasons why we say 360 degrees in a full turn. But are you happy that is kind of completely arbitrary? It's kind of somebody just looks at that and go, ha, let's just say 360 degrees in a full turn. Okay, yes, okay, they have got reasons for doing that, but it's still completely arbitrary. It's not really basing this unit on any properties of a circle, which is ultimately what a full turn is. Okay, so this is where radians come in. It's a better mathematical unit if you're looking at kind of mathematical properties. Okay. So radians basically say, well, look, let's not base it on factors or natural phenomena such as the Earth completing a full turn. Let's not do it arbitrary. Let's try and come up with an angle measurement that is based on properties of a circle, namely the radius. Okay? So look at this. If I draw myself out a circle, okay, so there's my circle-ish, okay? And if I draw in my radius, so here is my radius here, and I'm going to label that R, okay? Here is the idea. I'm going to try and say, okay, imagine I was walking around the edge of a circle. So imagine I started here, where my radius touched the circle. And imagine I was going to walk around the edge of the circle. And the distance that I'm going to walk around the edge of the circle is the same as the distance of one radius. So in other words, I start here, and I take a walk around the edge of the circle, which is exactly the same distance as whatever my radius is. Does that make sense? So I'm just kind of measuring whatever that distance is, my radius, and I'm just going for a walk around the edge of the circle. Now, can you see that I have swept out some angle? Okay, I've swept out an angle from here to here. So obviously that's got to be a radius as well. Okay. Now, whatever that angle is, so if I start here, walk around the edge of the circle for one radius length, end up here, whatever angle I've swept out is just 1 radian. That's how I define my radian. Okay? So that there is going to be 1 radian. Okay? Does that make sense? Yeah? Now, you notice the symbol that we give for radian. For a degree, we're talking about a full circle. So we put a little circle up there for the unit for degree. For a radian, if I make that a little bit bigger, we could use a little half a circle. And let me try and illustrate why. Why do we use a degree as a full circle and a radian as a little half a circle symbol? Let me try and illustrate why. If we know that a full turn consists of 360 degrees, how many radians are there in one full turn? So how many times does the radius fit in around the edge or the circumference of the circle?
Does it 2?
Not quite 2. Because 2 would be like there. It's 2 something though.
2 pi.
2 pi, perfect. Yeah? So you know that the circumference, so that the full length around the edge of the circle is 2 pi r. So therefore that means that a full turn is equal to 2 pi radians. Okay, 2 pi radians like that. Does that make sense? Yeah. So in other words, what we can say now, we've got a fundamental idea that 360 degrees, let's write it down here, 360 degrees is equal to 2 pi radians. Now, if we're giving our angle measurement in terms of pi, we tend not to write that little half circle. We tend not to write the radian symbol up there. Okay, it's fine just to leave it off. But this is the fundamental relationship. That a full turn is 2 pi lots of that radius, therefore it's 2 pi radians. Okay? But of course, if I look at this, like I've got 2 times pi, how much would 1 pi be worth? How many degrees? Yeah, good. So now do you see why we use this little symbol for the radians? Half a circle. Because if we look at like the base measurement, like 1 degree, okay, if we looked at like 1 of our angle unit, 1 of our radian unit, then basically what we're looking at is pi. Yeah? And pi we know is half a turn, it's 180 degrees. So because we're looking at half a turn, we tend to use half a circle up there as well. Okay, so, I mean, you don't need to understand the difference, just understand that that is a degree, that is a radian, but kind of the reason why is because if you look at the basic one, pi, then that's equal just half a turn. Okay? So, let's have a look at this. Does that make sense, by the way, the difference between a radian and a degree? So we tend to say radians are slightly better to use because they're actually basing it on properties of a circle, whereas degrees are kind of a little bit arbitrary. Yes, they've got loads of factors. Yes, the Earth is roughly 360 days to orbit the Sun, but it's still a little bit arbitrary, whereas radians, they're based on properties of a circle. They're more mathematical in some people's eyes. So, okay, let me play on this idea then. Let's see how we convert from radians to degrees and vice versa. So we've just established this relationship down here, that pi radians is equal to 180 degrees. Let's start there, okay? So if I wanted to ask you now, what would 90 degrees be worth? How many radians would 90 degrees be?
4 pi.
What have I done to get from here to here?
Divide 2.
Divide by 2, so I'm also going to have to divide this by 2 as well. So in other words, 90 degrees is pi pi by 2 radians.
Oh.
Does that make sense? Yeah? What about 45 degrees?
Pi over 4.
Good, because all I've done is just divided this by 4, so therefore I'm going to have to divide this by 4 as well. What about 30 degrees?
6.
Good, pi by 6. Because again, all I've done is taken this, divided by 6, so you're going to have to take pi, divide that by 6 as well. What about, I don't know, what about 120 degrees? Boy, well look, we've just said that 30 degrees is pi by 6. What are we going to have to do to 30 to get to 120?
Multiply by 3.
Multiply by 4.
4.
Aren't we? So it's going to be 4 pi by 6, which we can simplify to 2 pi by 3. Does that make sense? Yeah, so literally all we're doing here is we're starting off with this basic measurement. We know the fact that pi radians is 180 degrees, then we're able to work out all the other ones as well. So if I follow the same kind of logical technique then, how much would 1 degree be worth? How many radians?
I don't know.
What have I done to get from here to here?
Divide by 180.
Good, so what am I going to have to do here?
Divide by 180.
Exactly. So this is going to be pi divided 180. Yeah, so those two things are the same. Okay? So what that means then is that if I know how many degrees I'm interested in, 4 degrees, 5 degrees, 7 degrees, I just need to multiply whatever that is by pi over 180. So to get from degrees to radians, to get from this direction, all I'm doing is just multiplying by pi over 180. If I wanted to go the other way, okay, if I wanted to go the way, I could absolutely divide by pi over 180. Well, that's the same as timesing by 180 over pi, isn't it?
Mm-hmm.
Yeah? So to get from here to here, all I'm having to do is times by 180 over pi. And of course you can see that because if I go down here to 1 degree, I've divided this by pi, which means I'm also going to have to divide this by pi as well. Okay? So what I'm trying to show you there is how to get from degrees into radians, how to make that conversion. Okay? You can either just remember it, or how I personally tend to do it, is remember this relationship. Know that pi radians is 180 degrees, and then from that, you're able to get these two things, and you're able to work it out from there. Okay, good. So can I give you then, just for 2 minutes, can I ask you to convert these? So whatever I give you, I want you to convert it to the other angle measurement, okay? So number 1, can I ask you to convert 50 degrees into radians? Number 2, can I ask you to convert pi by 3 into degrees? Number 3, can I ask you to convert 2 radians into degrees as well for me? Okay, so 50 degrees, convert that to radians. 2 ways of doing it, either remembering these two, remembering this, or thinking about it up here. So to get from degrees to radians, you need to multiply by pi over 180. Yeah, so 1 degree is worth pi over 180, so therefore I need 50 degrees, so I need 50 times as much. So it's going to be 50 times by pi over 180. I'm personally just going to cancel that down to be 5/18 pi, like so. Does that make sense? Five over 18 times pi. So I've just simply cancelled the 50 and the 180 down to 5/18.
The next one, is it 40?
Let's see. So what did you say, sorry?
Is it 40?
It's not. No. So what we've basically done here, to get from radians to degrees, we've gone this way, so we need to multiply it by 180 over pi. So pi by 3, multiply by 180 over pi. Pi's cancel, 180 divided by 3,
60.
60 degrees. Yeah. And then finally, 2 radians into degrees. What are we going to have to multiply by?
180.
Yeah, over pi. Okay, so that's going to be 360 over pi. Now, actually, I say it's fine to leave it like that. It's not. The reason being is because when we work with radians, by default, they nearly always have a pi built in them. Admittedly, that one didn't, but nearly always, the reason why we work with radians, they've got a multiple of pi built in them, because you're looking at how many times the radius fits into the circumference, okay? So what you need to do is actually stick that in your calculator. Literally stick 360 divided by pi in your calculator and get it as a decimal for me. And do it as a decimal to 2 decimal places.
114.59.
114 or 140?
114.
114. Point
59.
59 degrees. Okay, so that's always a good point to point out. If you're working with radians, leave your answer in terms of pi, that's fine. But if you're working with degrees, don't confuse them. Make sure you definitely leave it as a decimal.